This video discusses the topic of the ellipse and some vocabulary definitions. An ellipse is a conic section. A conic section, also known as a conic, is a shape resulting from intersecting a right circular cone with a plane. The angle at which the plane intersects the cone determines the shape. Today we're discussing ellipses, and we can see the right circular cone in blue, and here in gray is the plane intersecting that cone. In red, inside, you can see a very small ellipse. Conic sections can be described by a set of points in the Cartesian coordinate plane. The signs of the equations and the coefficients of the variable terms determine the shape we're discussing. Remember, the signs of the equations are the positive and negative signs, and the coefficients are the numerical values appearing before variables. For example, in the statement 5a plus 3 equals 2y, the coefficient of the variable a is the number 5, and the coefficient of the variable y is the number 2. An ellipse is the set of all points x, y in a plane such that the sum of their distances from two fixed points is a constant. Each of these fixed points is called a focus. Note, the plural of focus is foci. To the right on the slide, we can see a figure of an ellipse. Here, we have labeled our two foci, and the green dot is where that point is exactly located in space for this particular ellipse. Every ellipse has two axes of symmetry. The longer axis is called the major axis, and the shorter axis is called the minor axis. Let's take a look at our picture. The major axis for this picture is labeled right here, and the minor is labeled above. So we can see for this particular ellipse, the major axis is along that x-axis, and the minor is following the y-axis. This isn't always the case. Ellipses can be turned sideways so that the longer the major axis is following the y vertically, and that the minor would be along the x. But for this example, our major axis is horizontal and our minor is vertical. You can see clearly from this picture that the minor is indeed shorter than the major. At the end point of the major axis is a vertex of the ellipse. The major axis has two endpoints, here and here, and they are both called the vertex of the ellipse. At each endpoint of the minor axis, we have a co-vertex of the ellipse. And here are the two co-vertices of this ellipse. The center of the ellipse is the midpoint of both the major and minor axes. The midpoint is the point directly in the center of those line segments. Taking a look at our diagram, we can see the center is labeled, it's this black dot, and we can kind of eyeball that and see, yep, that looks like it's the middle of both of those axes. The foci always lie along the major axis, clearly marked in this picture, and for every ellipse that you deal with, the foci will always lie along the major axis. Finally, we can note the sum of the distances from the foci to any point of the ellipse is greater than the distance between the foci. This is called the constant sum. What does it mean when we say the sum of the distances from the foci to any point of the ellipse is greater than the distance between the foci? Let's draw a picture. So we have one focus here, and we'll draw a line segment up to this point, and we'll take a line segment from the second focus to the exact same point. The sum of these lines, I'm labeling them x and y, will be greater than the distance between the foci, and the distance between the foci is this distance right here, and we'll label that d. So we have x plus y is greater than d.